Hello everyone. In today's session, we are going to explore Subflows, a powerful capability in Salesforce Flow that enables you to modularize your logic and improve automation scalability. We will start with a foundational introduction to Subflows, where you will learn what they are and why they are critical for building efficient flows. Next, we will look at the types of subflows supported in Salesforce and understand when to use each. We will then walk through the actions that can be performed within subflows, including supported elements and what limitations to be aware of. Once we have that baseline, we will shift gears into best practices. These will help you write clean, reusable, and performant subflows. After that, we will cover performance considerations such as governor limits, flow depth, and memory usage that can impact subflow execution. We will also call out common pitfalls to avoid, especially around handling variables and subflow design mistakes. From there, we will dive into the master subflow design pattern, which is a proven strategy for orchestrating complex automation in a modular way. I will walk you through a live demo using a recruiting app example to show how the pattern works in real-world scenarios. Finally, I'll give you a preview of our next session, where we will dive into screen flows, their power in building guided user experiences, and how to combine them with subflows for even greater flexibility. Let us start with the fundamental concept. What exactly is a subflow? In Salesforce Flow, a subflow is essentially a reusable auto-launched flow that is invoked from another flow using the subflow element. You can think of it like a reusable method or function in programming, allowing you to encapsulate a piece of logic and call it from different automation contexts. There are several key advantages to using subflows. First and foremost is reusability. If you have logic that needs to be executed in multiple flows, like checking for duplicate records or sending notifications, you can build it once as a subflow and reuse it anywhere. Secondly, subflows promote a modular design, which makes your flows easier to manage, debug, and maintain, especially in large orgs where automation logic can get complex quickly. And finally, they enable better collaboration and scalability. Different team members can work on subflows for individual features, and these subflows can be integrated into a master flow, allowing for parallel development, faster delivery, and more scalable solutions. Before we dive deeper, it is important to clarify a common confusion around subflows. In our earlier session, we have reviewed record-triggered flows, which are type of auto-launched flow with a trigger. They run automatically when a record is created or updated. However, subflows refer specifically to auto-launched flows without a trigger. These do not run on their own, but are especially invoked from another flow using a subflow element. So while all subflows are auto-launched flows, not all auto-launched flows are subflows. This distinction is key when designing modular reusable automation. Now that we understand what a subflow is, let us talk about why we use them and how different characteristics of subflows serve broader design goals. First, let us look at triggering. Subflows are always invoked from a parent flow. They don't run on their own. They are like behind the scenes workers that perform a task when the master flow tells them to. They can be invoked from record triggered flows, scheduled flows, or even other subflows. Their true strength lies in reusability. They help encapsulate logic like validations, record creation, or assignments. They are ideal for processes that occur across multiple objects or flows. Example, check candidate eligibility, send email notifications, etc. Reuse ensures consistency across automations and saves time. With that comes modularity, where each subflow has a single responsibility. This makes flows easier to build and understand. Subflows support component-based architecture. Each subflow handles one logical function, like in software engineering, makes it easier to separate responsibilities, like one subflow validates inputs, another creates records, enables individual development and testing. Subflows also drive simplification by offloading complex logic from your main flow, keeps the main or master flow clean and readable. Complex branching logic or loops can be abstracted into subflows, reduces clutter and confusion in large automation. As your org grows, you will also value the flexibility subflows bring. You can pass data in and out, use them in different paths, and customize behavior. Subflows can accept input variables and return output variables. Use conditional logic within subflows to handle edge cases. Easily swap or update subflows without modifying the main flow. Finally, they shine in maintainability. When a change is needed, you update the subflow in one place and every flow uses its benefits instantly. This makes them perfect for scalable enterprise-grade automation. Changes can be made in one place, that is the subflow, and reflected wherever it is used. It makes it easier to debug, test, and deploy, and great for long-term automation governance and org scalability. Subflows in Salesforce support a wide range of actions, allowing you to build powerful logic with reusable components. Since subflows are built using auto-launched flows without a trigger, they can include elements like get records, create or update records, assignments, loops, and decisions. It is highly recommended to not do transactional update and creation of records using create or update record actions, but to use create record for recording any logging information. They also support more advanced features such as invoking Apex actions, looking up custom metadata, and even calling other subflows, allowing for deep nesting. In certain use cases, you can also include pause elements, but only when used inside a scheduled path. However, it is important to note that screen elements are not allowed in subflows since they are meant to run in the background without user interaction. Similarly, email alerts, quick actions, and charter posts are also not supported directly unless they are wrapped into a custom Apex action. Understanding these supported actions helps ensure you design subflows that are both functional and compliant with platform limitations. Now that we have explored the types of actions Subflows support, let us shift our focus to some best practices that will help you build clean, scalable, and high-performing subflows. First, it is essential to establish clear and consistent naming conventions for your subflows. This improves organization and makes it easier for both you and your team to understand what each subflow is doing at a glance. Use names that reflect the subflow's purpose, like Subflow Validate Candidate, or Subflow Update Application Status. Next, be mindful of your DML operations. Avoid placing DMLs like create, update, delete inside loops, and consolidate your operations wherever possible. This helps maintain governor limits and improve performance, especially when subflows are invoked frequently or in bulk. Another key practice is to design your input and output variables thoughtfully. Clearly define what data your subflow needs and what it should return. This ensures smooth integration with the parent flow and keeps your data flowing correctly between steps. One of the biggest benefits of subflows is the ability to reuse logic. Identify repeatable processes like assigning tasks, sending notifications, or applying business rules, and encapsulate them in subflows. This reduces duplication and makes updates much easier. Along similar lines, aim to modularize complex logic. Break down large processes into smaller, focused subflows. This not only enhances readability and testability, but also enables team members to work on individual pieces in parallel. Don't forget to document your subflows thoroughly. Use descriptions on the flow itself and for each input-output variable. Consider adding an annotation element inside the flow to explain its purpose, assumptions, and any integration details. Well-documented flows are easier to maintain over time, especially in team environments. Finally, always consider adding error handling path where needed. Use fault connections to log issues, notify users, or route exceptions to admin queues. This proactive handling will save hours of debugging later. In the next slide, we will dive deeper into some performance considerations that are especially important when using subflows in larger or high volume orgs. Building on the best practices we just discussed, let us now explore some key performance considerations when working with subflows. While maintaining consistent naming, reducing unnecessary DML operations, and clearly managing input-output variables lay the groundwork for good flow design, high-performing automation requires an additional layer of strategic thinking. First, it is important to avoid placing logic-heavy subflows inside loops. If a subflow contains data lookups or DML statements and is called inside a loop, it can lead to governor limit violations. Always extract logic outside loops and process collections in batches where possible. Next, strive to bulkify your subflows. This means designing them in a way that supports processing multiple records at once using collection variables instead of individual ones. So they work well in bulk triggered flows and don't introduce bottlenecks. Also consider the depth of subflow nesting. While Salesforce does allow subflows to call another subflows using nested design, deeply nested flows can become hard to debug and may consume excessive CPU time or memory. A good rule of thumb is to avoid nesting more than 2 to 3 levels deep unless absolutely necessary. Lastly, always look for opportunities to optimize your DML statements. This includes combining updates into a single operation, updating only changed fields, and avoiding redundant writes. These small adjustments can have a significant impact on flow performance, especially in high volume environments. In the next slide, we will explore some common pitfalls to watch out for when designing subflows. In our previous discussion, we explored performance best practices like avoiding loops, bulkifying logic, limiting nested depth, and optimizing DML statements. These strategies help us build efficient flows, but it is just as important to understand the common pitfalls that can compromise those efforts if we are not careful. One of the most frequent mistakes is performing DML operations inside a loop. This can quickly hit governor limits and cause your flow to fail at runtime, especially in bulk data operations. Instead, aggregate your changes and execute DML outside the loop or perform a single DML in the master flow. Another subtle but critical issue is improper handling of null output variables. Your subflow is expected to return data and the calling flow doesn't check for nulls before referencing it. You may encounter unexpected behavior or flow errors. It is also easy to over-engineer your solution by creating deeply nested subflows. While modularization is good, going too deep can make the automation harder to understand, debug, and maintain. Always aim for simplicity where possible and consolidate logic when appropriate. By proactively addressing these common pitfalls during your design phase, you will ensure that your subflows are not just functional but also reliable, scalable, and maintainable in the long term. In the next section, we will see how to bring it all together using the master subflow design pattern, where a master flow acts as an orchestrator, calling subflows for tasks like validation, record assignment, and stakeholder notification. This pattern is powerful for building scalable, modular automation in enterprise Salesforce orgs. Building on our earlier discussion about common pitfalls, let us now shift focus to a powerful design approach known as master subflow design pattern. This pattern helps you orchestrate complex business processes in a clean, modular, and reusable way, especially when you are dealing with multiple steps that can be logically separated. In this pattern, the master flow acts as a central controller, guiding the overall process from start to finish. It doesn't handle every detail itself. Instead, it delegates specific responsibilities to dedicated subflows. This keeps the master flow simple, readable, and easy to modify when requirements change. In our example, we have identified 3 key subflows that demonstrate this modular approach. The validate subflow ensures the input data is accurate and complete. It can handle tasks like checking required fields, enforcing business rules, or even calling Apex validations. The assign subflow determines the correct owner or team to route the record or task to, using logic based on role hierarchies, queue membership, or custom assignment rules. The notify subflow handles communication, sending alerts or emails to relevant stakeholders when the process is complete, ensuring everyone stays informed without manual follow-up. By designing our flows this way, we not only improve maintainability, since each piece can be updated independently, but also gain flexibility and reusability, as each subflow can be used in other flows as well. Let us now dive into a live demonstration of this master subflow design pattern in action using a real-world recruiting scenario to see how each subflow contributes to the end-to-end process. Let us walk through this powerful slide that demonstrates the core architectural principles behind the master subflow design pattern in Salesforce Flow. We start with pattern 1, where a single parent record update, such as a job application, triggers multiple downstream child processes. This is common when an update to a record must initiate several logical branches, like validating data, triggering notifications, or preparing records for approval. Each of these branches can be handled by a subflow, keeping the logic clean and modular. Next is pattern 2, which is even more performance critical. Multiple child level processes independently analyze criteria and contribute data updates to the parent. But the actual update to the parent record is performed only once, centrally in the master flow. This is especially useful for governor limit safety and reducing recursive automation. We demonstrate this in a real-world implementation using our recruitment application. We also apply performance optimization techniques like avoiding DML in subflows, preventing nested flows from causing recursion, and minimizing flow depth. Finally, we wrap this pattern with best practices for flow design, such as reusability, modularity, and clear input-output variable structures to ensure your solution is scalable and easy to maintain over time. This example shows how the master subflow pattern is applied in real-world scenarios. In this case, when a position is marked as closed in our recruiting application, as soon as the position status changes to closed, the position closer master flow is triggered. The first thing this master flow does is to find all related job applications for that position. It then loops through each application, treating them one at a time, and for every application, it invokes 5 focused subflows. Let us go through each subflow. The send rejection notification subflow ensures that candidates linked to the application are notified via email or chatter about the closure with a message that reflects the reason or stage of rejection. The update application status subflow sets the job application status to a terminal value like closed position withdrawn or rejected position closed based on business rules. The create follow-up tasks subflow is executed when any recruiters need to follow up with candidates or hiring managers. The subflow creates relevant task records for accountability. The archive document subflow can trigger document tagging or integrations as needed. Any uploaded resumes or review documents linked to the application may be marked as archived or moved to a different location. For compliance or internal tracking, the generate reports subflow can log closure details into a custom object or prepare a handoff summary for operations or analytics teams. The key takeaway here is that the master flow controls the loop, but each subflow is responsible for a specific unit of work. This keeps the logic modular, reusable, and scalable, and ensures we are not repeating logic or hard coding steps across applications. Also note, all changes to job application records can be collected and updated in one DML operation, preserving governor limits and boosting performance. Now let us dive into this application and see that in action. I've already created this example. Let me go through the example in detail. I went to setup, and from quick find I entered flow and selected flows. So I created a position closer master flow. So I'm opening that right now. So this flow is a record triggered flow which is executed when the record is updated, and it is performing actions and related records, indicating that this is an after save flow trigger. Remember that subflows can only be invoked in after save flow triggers. Now within this flow, the first thing that I'm doing here is I'm retrieving all the related job applications on which I want to act and perform some actions. So I'm retrieving all the job applications associated to the position that is in action right now. After getting the related job applications, I'm iterating through each of these job applications and performing 5 different business processes for each of the records or job applications associated to this position. The first thing that I'm doing here is I'm calling the send rejection notification subflow. This subflow ensures that candidates linked to the application are notified via email or chatter about the closure with a message that reflects the reason or stage of rejection. I am passing application record or the job application record that I'm working on, as well as the position record as 2 input variables to this subflow. And this subflow is returning me a rejection task. Let me open this subflow. As I told you earlier, subflow is an auto-launched flow without trigger. So if you want to create a subflow, you will go to flows and click on new flow, and you will select auto launched and auto launched flow no trigger. So let me go back to the flow and let me go to the subflow that I have already created. So I'm opening the referenced flow. This auto launched flow is sending a rejection email. So it is sending a rejection email to a candidate using a email with a subject and body. The next thing that I'm doing here is I'm creating a task record. So if you go back to the elements here, if you see, these are the input variables that I have created for this particular flow, so that whoever is calling this flow, in this case the master flow, will send this value. So that's why I created this variable as application record, which is of type job application, which is available for input. And I created one more variable called position record, which is also of type available for input, which is also of type record, position record. Created a task record output variable, which is available for output. So after sending the rejection email for this particular job application, I'm creating a task saying that an automation rejection notification is sent via the flow, and I'm creating a task and associating it with the job application. If you see here, I'm not using a create records action, but I am instead creating a task record as an output variable. So it is always a good practice to not perform any DML operation within a subflow. So I'm just assigning a task record and sending it back to the master flow. So once the master flow retrieves that rejection task, so I'm assigning that rejection task to a task list variable. I'm creating a task list variable and I'm adding this rejection task that was returned by my subflow to this task list variable. Here also I'm not doing a create records action directly, because we should not perform a DML operation in a loop, or else you will run into too many DML statements error. I'm calling the next flow, which is called update application status subflow. This also takes an application record as an input and returns a note as well as job application as output. So let me open this subflow. So in this subflow, if you observe, I'm doing two assignments. Here, if you see the variables, this is the input record and this is the output application record. So I'm updating the output application record status job application name with the name called position closed. So I'm changing the name of my job application through a assignment operator. I'm not calling an update action here. Similarly, I'm also creating a note record. Note is a standard object. So I'm creating a note body saying that this application was automatically updated to not selected, status due to position closure, the position was closed, and all this data. I'm creating a body and I'm constructing a note and associating that note to the application so that the end users know that why this application was closed. So these two, I'm creating variables and sending it back. So if you observe here, I have a note variable and an output application record variable. These two, I'm sending it back to the caller. So in this case, the master flow. So once the master flow retrieves those two values, I'm storing them in local variables called note and job application. And using assignment, I'm adding the application to application records list variable, note to note records list variable, so that I can do a DML on this list variable or collection variable towards the end. The next business process that I am performing is creating follow-up tasks for my hiring manager. So this flow also takes an application and position record as two attributes because my hiring manager is on my position record. So I want to notify him for a follow-up task, and application record has the data for application. So these two records I'm sending as input, and this is also returning me two different tasks, one for hiring manager and one for recruiter. So both these tasks I'm constructing from the subflow and sending it back to the master flow. So let us see the subflow. So in this subflow also, I'm not performing any DML operations. I'm just creating assignments and creating variables. So this subflow has an application record as an input and position record also as input. These two are input variables. So these two values are sent from the caller, which is my master flow. And here I'm constructing a hiring manager task as well as recruiter task. Two task variables I'm constructing because the position is closed. So since this position is closed, I'm saying like, please review the candidate's application and then add him to our pool for our upcoming opportunities. So I'm getting the hiring manager from the position record and I'm creating a task and associating it to this is assigned to the hiring manager of the position. So I'm creating one task here and I'm creating one more task, which is recruiter task. I'm creating one more task for recruiter and associating it to position. The hiring manager one, I'm associating it to application. So I'm creating two different tasks. These two tasks are output variables. These will be sent back to the caller, which is the closure flow. After getting these values, I'm storing them in local variables and then adding it to the activities list. I'm saying task list.add hiring manager task, add recruiter task. I'm using the same task list that I'm using in my first section. Then the next action that I'm performing is archival, because once the position is closed, I want to archive some documents. For this also, I'm sending application record as an input. So let us see this flow. This subflow has an input variable, which is application record, and I'm creating an activity record from this. I'm also creating an activity list variable here. From the job application, I'm getting application records, the documents associated to the job application. If job applications are available, I'm counting these job applications. Then if job applications are available, if this returns a value, then I'm creating two tasks. If it is not available, I'm creating only one task. So here I'm creating a task which says create document archive activity. So I'm just creating an activity under the application record, adding it to this list, creating one more activity again with the application record, saying that application documents have been marked for long-term storage. So I'm creating two tasks and adding it to the list. If no documents are found, then I'm creating a task saying that no documents were found under this application and adding it to the same activity list. So I'm returning an activity list from here to the master flow. So once I get the activity list, I'm adding it to the task list. So this activity list, whichever is returned, I'm storing in archival tasks and adding it to the task list. After coming out of the loop, so I'm also doing an update. I'm calling one more subflow to generate position closure report. So this will also take position record and processed applications, the job application list as two arguments as inputs, and it will return one task as an output. So let us see this flow. So this will also create, it will do an application count. The processed applications, whatever were passed, I'm counting them using the count formula, and I'm creating a closure task. I'm creating a task saying that the position is closed and summary of the position and everything. And once I have closed it, I'm sending this report to the management. I'm sending an email saying that the position record has been successfully closed, and I'm returning this task that I have created to the call. So once I get the task, I'm adding it again to the task list. Now, once everything is done, I'm calling the create records action on the task list. Instead of doing each task's insert separately, I'm doing it in bulk towards the end so that it will do only one DML operation. I'm also doing job application update, which also I'm doing once. I'm creating note records also once. So I'm doing 3 different DMLs on 3 different objects, one at a time. Instead of doing multiple DMLs, I'm doing one single DML on these objects. So this way I will avoid too many DML statements. So if you perform your operations in this fashion, your application or your flow will be performant and it will be scalable. This slide highlights another variation of master subflow pattern where we start with a change in a job application record such as status update, interview result or offer action. As soon as a change is detected, the record triggered flow on job application fires and launches the application master flow. This flow does not directly update any parent or related records, yet instead it delegates all domain specific logic to 5 specialized subflows, each focusing on a different business scenario. The application count changes subflow calculates how many job applications exist for the associated position and how many are still in progress or have been rejected. The interview metrics subflow evaluates total interviews scheduled and completed across all applications tied to the position, giving hiring managers a pulse on pipeline activity. The reference check tracking subflow checks how many candidates have completed reference checks and surfaces potential bottlenecks in the screening process. The offer metrics subflow counts how many offers were extended, accepted, or declined, enabling accurate forecasting and reporting. The rejection metrics subflow identifies how many candidates were rejected for a particular position and the common rejection stages. All these subflows return partial updates for a single position record. Once all subflows finish execution, the master flow consolidates these results into a single position record and performs just one DML operation. This pattern showcases how subflows can intelligently transform distributed changes from multiple job applications into a unified summary at the position level, while ensuring that logic remains modular and reusable. No redundant updates occur. You maintain governor-safe automation. This is especially effective in real-world enterprise implementations where business reporting, dashboards, and hiring KPIs need to stay in sync with actual data activity across the recruitment funnel. I've uploaded the flows related to this example in GitHub, and I'll be sharing the link in my website TrailblazerTutor.com. Please do visit and download the example and check it out. This slide highlights the key benefits of designing your flows using the master subflow pattern, especially when building automation at scale. We begin with modular focused components. Each subflow is responsible for a specific task like summarizing interview results, validating candidate data, or calculating hiring stats. This separation of concerns makes your automation logic much easier to understand and manage. Next, we will discuss easy to maintain and extension functionality. When business rules change, you only need to update the relevant subflow instead of modifying a massive monolithic flow. You can also swap in new logic or plug in additional subflows without refactoring the entire process. Next comes optimized performance, which is a direct result of reducing redundant DML operations, using decision points efficiently, and avoiding loops inside flows. The master subflow pattern lets us gather all changes and apply just one update per object, keeping us well within Salesforce governor limits. Next, we focus on reusable subflows. By designing generic subflows that accept input and return output without performing DML, these components can be reused across different flows, reducing redundancy and improving consistency. Lastly, testable business logic. Each subflow can be tested independently, which simplifies validation and helps developers and admins pinpoint issues quickly during development or after deployment. Together, these principles lead to high quality, maintainable, and scalable flow-based automation, a must-have approach for enterprise Salesforce implementations. Before we wrap up, I would like to remind you how you can continue learning and get the most out of this Salesforce training path. If you have found this session valuable, please like the video, subscribe to the channel, and turn on the notification bell so you never miss a new lesson. It is a simple way to stay updated and also helps us reach more learners like you. And for those who want to take their learning further, visit TrailblazerTutor.com. There you will find the complete Salesforce learning path with step-by-step demos, detailed assignments, and plenty of hands-on exercises to help you apply what you have learned in real-world scenarios. Your engagement, whether it is a like, a share, or a subscription, motivate me to keep producing high-quality, practical Salesforce content for you. So thank you in advance for being part of this learning journey.